Okay, so our last method of solving that we're going to learn is to solve systems by graphing. This is method number 3. You are going to need your graphing calculator for this, so make sure you have that handy. So I'm going to show you how to solve by graphing by hand and how to solve by graphing using your graphing calculator. So first, to do it by hand, you do need to get your equations in slope-intercept form, or y equals form. So y has to be by itself. So get both equations in the y equals mx plus b form. So you have to do some solving for y. So you'd move the x term over if you have to, and then divide by any coefficients in front of y. And then you are going to graph both of your lines on the same coordinate plane and look for the intersection point. And look for intersection point. And the point where they intersect will be your solution. So for example 1. So in this case, our first equation here is x plus 5 equals 5. There is no y. And so if we get x by itself, we get x equals 0. Remember, whenever we have just x equals a number with no y anywhere to be seen, and this is a vertical line. So a vertical line at x equals 0 will just be that y-axis there. Oops, let me get it better. Okay, so that's our first equation. And our second one, we need to get y by itself. So in order to get y by itself, we have to move our x term over. It's a positive 3x, so to move that, we would subtract 3x from both sides. This negative stays with the y. And that y is not by itself yet because it's negative. We need just a positive y. So this is essentially like saying negative 1 times y equals negative 3x plus 3, right? That's what negative signs are. They're really like negative 1s being multiplied. So to get that y by itself, we divide everything, every single term, by negative 1. So we'd have y equals 3x minus 3. So if we graph that one, it has a y-intercept of negative 3 and a slope of 3. So we go up 3, right 1, up 3, right 1, up 3, right 1, or opposite, down 3, left 1. We connect our dots. And so our point of intersection is this point right here. It's the point 0, negative 3. Okay, I want you guys to try example 2. So y is already by itself for both of them. So you're just going to graph those two lines and find the points where they intersect. So go ahead and try example 2. Okay, and now I'm going to show you how to do this with your calculator. So the first step's the same. You still need to solve both equations for y. So you have the y equals mx plus b. And then I'm going to use example 3 when we do this. So we need to get y by itself for example 3. So I have to get rid of my x term. So I'm going to subtract 2x from both sides. So I'll have 3y equals negative 2x plus 6. Then I have to get rid of that 3 in order to get y by itself. So that's 3 times y. So to undo multiplication, we divide everything by 3. So we'll have y equals negative 2/3 x plus 2. And then our second one over here, to get y by itself, all we have to do is subtract 2x from both sides. We'll have y equals negative 2x minus 2. So to type this in our calculator, get my video here, so that's my calculator. So when you have your calculator, you're going to hit the y equals button, turn it on, and then hit the y equals button. You're going to type your first equation into y1. So in this case, we do have a fraction, so you want to make sure fractions are in parentheses. So parentheses negative 2 divided by 3. Make sure you use the negative sign right here, not the subtraction sign. Close the parenthesis, and then x, you're going to use this xt theta n key, and then plus 2. So that's your first equation. Then you hit the down arrow to go to y2. You're going to type in your second one. which is negative 2x minus 2. So negative 2x minus 2. Once you have them both y1, y2, you can hit the graph button, and it will graph your two lines for you. If at this point, if you cannot see where they intersect in your window, if you hit the zoom button and then go down to option 0, which is zoom fit, it will change the window so that it can see the intersection points. You want to make sure that intersection point is visible in your window. And then to find the point of intersection, if you hit the second, so while you're on this screen with your graph, if you hit the second and then trace, then select the fifth option, intersect. Hit enter, and then it's going to ask first curve, just hit enter. Second curve, just hit enter. It wants you to guess, just hit enter. And then your intersection point pops up at the bottom. So negative 3, 4. Okay, so negative 3, 4. Okay, and so that is how you can use your calculator. So I want you guys to go ahead and try example 4. So you have to get y by itself first. Plug it into your calculator, y1, y2, and then just follow the directions up here to get that intersection point. So go ahead and try example 4. Okay, and now example 5. So if we were to graph these two, so x plus 1, so y-intercept of 1, slope of 1, and then x plus 5, so y-intercept of 5, slope of 1. So these two lines are parallel, which means they'll never intersect, and since the solution to a system is the point where two lines intersect, and that's never going to happen for these, this system has no solution. So whenever you have parallel lines, that means you have no solution, and that's because they're parallel and will never intersect. And so looking at the equations, that's when we have the same slope, so they both had that slope of 1, but they had different y-intercepts. Right, one had a y-intercept of 1, one had a y-intercept of 5. So if you're looking at the equations, if it's the same slope, different y-intercept, those are parallel, it's going to be no solution. Or if you graph it and you just see they're parallel, it's no solution. If you got as far as plugging it into the calculator, you tried to find the intersection point, the error will pop up where it says like no sign change. That's how you'll know it's no solution. Now example 6. So we have, to get y by itself, we have to subtract x. In the second one, we subtract 2x from both sides. And then divide everything by 2. So we can see here that our two equations are identical. And so that means that we have the same line. And so if it's just the same line graphed on top of itself, we're trying to find the points of intersection. Well, it's going to intersect at every single point. This is where we have infinite solutions. This is when you have the same line. And that's because the same line, they intersect at every point. One important thing here, though, since it does intersect at every single point, if you did it in your calculator is just going to tell you the intersection point is whatever point the cursor happens to land on first. So the calculator won't tell you its infinite solutions. It might be a little misleading. So just be careful. Calculator will tell you one of the infinite points. So even though the calculator tells you, oh, here, this one's an intersection point, you have to have that your answer is actually infinite solutions, because it really intersects at every single point to infinity. So even though your calculator won't clarify that, you have to know. So the only time an error will pop up is if it's no solution. Infinite solutions you just have to be aware of, so be careful. If you ever have the same exact line, that's infinite solutions. So we've learned 3 different methods now for graphing systems. We have graphing, substitution, or for solving systems, graphing, substitution, and elimination. So when we are going forward and we're solving systems, you can solve any problem with any 3 of them. All 3 will work. It's just sometimes one method is a little quicker or easier based on what the equations look like to start. But if you have your favorite and you just like if you love substitution and you just always want to use substitution, you can. You just have to be careful. Sometimes there'll be some fractions that pop up, and you just have to make sure that you're not doing any calculating errors when you're solving. So even though, again, if a problem asks you to use a specific method, that's usually just because that method is like the easiest one to use. It requires the least amount of work, but you can use any method that you want. But if you're trying to pick between which ones to use, graphing is usually the best option if y is already by itself for both of them, or it's easy to get y by itself. Because that's what we need to have y equals in order to graph by itself. Oh, for both. Or it's easy to get by itself. Like we just have to subtract one term over. Substitution is the best if one variable, either x or y, is already by itself, or if it's easy to get that variable by itself. So here, I'll just do kind of examples. So for graphing, if it looked like, something like this. Like here, this one, y is already by itself. This one, you would just have to add the 3x over, and then y is by itself. So that's a pretty easy one to do by graphing. For substitution, if we had like something like this, here x is already by itself, so you can just go right to plugging that in for x. Elimination is kind of the best if just every variable has a coefficient. Every variable has a coefficient, meaning you're gonna probably end up with fractions if you tried to solve for y or solve for a variable. So something like that, where there's a number other than 1 in front of all the variables, elimination is probably going to be the best. So again, any 3 will work. You can pick your favorite. It will work. Some just might take a little bit more work depending on how the equations are set up. So here, solving by graphing is your quick check. So go ahead and do that. Self-assessment. Let me know or bring any questions you have to the Google Meet.